Good evening, my YouTube viewers. It is Crystal here, and I'm here this evening to go over a code with you for the competition that I entered with Kaggle's Playground Competition Season 6, Episode 7. And so basically, there were lots of missing values in the data set that we were given. And so basically for the training data set, I just deleted all of the missing values. But for the test data set, I couldn't delete the missing values. And the reason why is because you have to submit your work in a certain format. So for the test data set, if the missing value was an object or a text or a category, then I just wrote the word not listed. And then if the missing value was a number, then I selected the mean of the column that data was in. And basically what I did was, obviously wasn't sure exactly what to do. I wasn't sure the exact way to go about it. And the reason why is because you have to make a lot of assumptions when you are imputing values. And so I tried to impute the missing value with the mean of the column, and then I tried to impute the missing value with the median of the column, but I've got a higher accuracy with the mean of the column than I did the median of the column, so I stuck with the mean. But there are other ways that you can impute it as well, like you can just say a number. You can just put a standard number in there, like -1 or something like that, but I wasn't really sure exactly how to go about it. And since I had a slightly higher level of accuracy with the mean than I did the median, I decided to go ahead and stick with the mean. But if you go onto the sklearn library, there are several ways that you can actually impute a missing value, such as KNN. You can use a simple imputer, but I didn't use sklearn's simple imputer. I just replaced the missing value with the mean of the column. And then, but you can go into sklearn and try the simple imputer or try the KNN imputer if you want to be daring. But I didn't want to be daring. I just decided to use a tried and true methodology. In addition to that, like I used the Extra Trees Classifier as my model. And the thing is that with the Extra Trees Classifier, the default of the number of estimators is 100, and so I tried to improve my score, so I used 1,000 estimators instead of 100 estimators, and so that very slightly improved my score. So I use the Extra Trees Classifier, and you can work around with the hyperparameters in the classifier to see if you can improve your scores, because the Extra Trees Classifier is set to defaults, but if you want to try other hyperparameters, you can always do that. And so that's what I did in this competition question. Now, I started working on the competition yesterday, but I didn't get to finish it. I started working on it like maybe 6 o'clock in the morning, but I had to leave at like 9 o'clock in the morning to go take care of some personal business, i.e. go to Argos and pick up a new bed because my bed was broken, and so I had to get a new bed. And so I only got a chance to work on the competition question for 3 hours, and then I had to put it away. And then so I think it was maybe last night, maybe I worked on it some yesterday afternoon. Yeah, maybe I worked on it some. No, I didn't work on it yesterday afternoon because I was putting the bed together, but maybe it was this morning. Maybe this morning I got up and I finished the competition question. And so I got like an 82% accuracy whenever I was checking the mean and 100 estimators and balanced weight for the class weight. But I tried to see if it would improve with the median, and it didn't improve with the median, so I decided to stick with the mean. And then I tried 1,000 estimators instead of 100 estimators, and my score just very slightly improved. And so there's lots of things that you can do to try to improve your score. I think one of the main things that you can do to improve your score is to work on how you impute the missing values. That's one of the main things that you can do to try to improve your score. But I'll go ahead and go through the code, let you see the code that I got. And so you can see that I got 83%. First thing that you do is you define your problem statement, which is you're going to predict on the health of students. And then we're going to import our libraries. We're going to import NumPy as NP to perform numerical computations in the program. We're going to import pandas as PD to manipulate the data frames to process data. We're going to import OS to go into the operating system. We're going to import sklearn to give us machine learning functionality. We're going to import matplotlib.pyplot as PLT to help us to make charts. And we're going to import Seaborn as SNS also to help us make charts. So the first thing that we do after we've imported our libraries is we want to retrieve the files used in the competition. And so we do that by using OS to go into the directory of the competition and retrieve the files. So there were 3 files. These were CSV files, being sample submission, train, and test. So now what we want to do is we want to take these CSV files and we want to convert them to data frames. And so what you want to do is you want to be able to see all of the columns of data. So you have to set the option to display maximum columns in pandas. And then after we've done that, then we take the CSV files, train, test, and sample submission, and we convert them to data frames using pandas. So now we've got a train, test, and submission data frames. So you can see the train data frame, and you can see what's unusual about this data frame is you have the health condition and column 1. So column 0 is the ID, or really you've got an index, and then you've got column 0 is your ID, and column 1 is your health condition. So instead of the health condition being at the end of the data frame, which is normally what it is, in this situation, the health condition is going to be at the beginning of the data frame, and we have 15 columns of data. So we do train.info, and when you do train.info, you can see that your ID is an integer, your health condition is an object, and then you've got some floats and some more objects. So that's telling you what kind of columns you're going to be dealing with. We check for any null values, and you see we've got lots of null values. And so what I decided to do was I decided to drop the null values using drop NA. And then after I dropped the null values, I check for null values again, and there's no more null values. But when you drop the null values, it about halved the length of the data frame. And so that's one thing that you have to take in consideration, because you can drop all of the null values and then you would have less rows of data, or you could impute the null values. And I just decided that I would just drop all the null values, and that pretty much halved my number of rows of data. So whenever your number of rows of data decreases, then that means the chance of accuracy is going to decrease as well. And the reason for that is because you want to have as much data as possible to train. You want to train your model on as much data as possible to get as much accuracy as possible. So now what I'm doing is I'm using the describe function so you can just see some statistics about the trained data set. And I think in the competition that I entered last month, I didn't do the describe, and I was saying, oh, I should do the describe. So I'm doing the describe this time. And so the describe lets you count the number of rows, gives you the median, the standard deviation, the minimum value, the 25 percentile, which is the first quartile, the 50 percentile, which is the second quartile, the 75 percentile, which is the third quartile, and the max. And then so it gives you all that data. So if you want to know the statistics of the trained data set, then you just do the describe function and it will give you that information. And so now what we're doing is we're checking the test. So the test does not have a target. The test does not have a health condition. And so you only have 14 columns of data instead of the 15 columns of data in train. So we check the info, and you can see that the columns of data, or the features in test, are the same as the features in train, except for train has a target and test does not. So we check for null values, and you can see we've got a lot of null values. But in this instance, you cannot delete the null values. You have to you have to impute them. And so that's where a lot of the problem is going to arise, and it's going to affect your accuracy. And there's lots of ways that you can impute those null values. And you can always look on the internet and say, please give me the ways to impute null values, and then you'll find out lots of ways to do it. What I decided to do was just impute the null value. If it was an object column, just say not listed, and if it was a numeric column, just give it the mean of the column, because you know, there's lots of things that you can do and lots of choices that you have to make. If it was a numeric column, I could have given it a number, such as -1 or something like that, but I decided just to make it the mean, which gave me a slightly higher accuracy than a median. So now we're going to impute the null values, and so we're going to do what I already had said. So basically, if the D type of the column is object, you're going to fill the missing value with not listed. And if the D type of the column is float, then you're going to fill the missing value with the mean of the column. And you can go into sklearn. They have a simple imputer function, and there are some things that you can do with simple imputer, but I just decided to make it the mean of the column. But there's lots of ways that you can impute missing values, and you can do a search on the internet and find some of those ways to impute missing values, because I only used one way. So after we'd imputed the missing values, you can see that we don't have any missing values now. They've all been replaced. And now we use the describe function, and so the describe function is giving you the statistics of the test data frame. And now we have the submission data frame. And this is what Kaggle wants to see when you submit your work. So now what we have is we're going to drop the ID column. Reason why we're going to drop the ID column is because Pandas automatically indexes every row of data, so you don't need the ID column. That's just redundant, and it might actually introduce noise into the model when you're training it. And now what we're going to do, we're going to create a target from the trained data frame, because the target is in the trained data frame. So target equals train.pop health condition. So you're going to take the column health condition out of the trained data frame, and you're going to make it your target. And then what we're going to do is we're going to create a histogram of the target. So this is a histogram of the target. You can say you've got a few people who are unhealthy, a few people who are fit, and you've got a lot of people who are at risk. And what this is telling you is that you have an unbalanced data set. You've got an unbalanced data set, and it's primarily the health status of most of the people is at risk. A few people are unhealthy and a few people are fit. So we're going to analyze the trained data frame. So what we're going to do is, if it has a number of unique values are greater than 5, then what you're going to do is you're going to create a histogram. But if the number of unique values is equal to or less than 5, then you're going to create a pie chart. And so we're going to have a function here called def fmt brackets x, and it's going to return a percentage value of x and the total times x divided by 100. And so what we're doing is now we have a histogram of every column of the trained data set, and if it has number of unique values greater than 5, it's a histogram. Otherwise, it's going to be a pie chart. So you can see that the sleep duration is almost a normal bell-shaped curve, but it is skewed somewhat to the left. So that's interesting to note. And then so most people sleep about 7 hours a night. So the heart rate, again, is almost, it looks to me like a normal distribution. And the main heart rate is maybe around 75. The BMI, that's your body mass index. Again, that looks like a normal distribution. And the main BMI is 22.5. That doesn't look too bad. Calorie expenditure is sort of like a normal, but a few people were 2,000 calories, but most people were between 2,000 and 2,500 calories. Step count, that looks like a uniform distribution. So basically that's telling you how many steps a person has walked in a day, and that's definitely not a normal distribution. It resembles a uniform distribution, really. Exercise duration is close to a normal distribution, except for the 0 frequency. And then basically what the 0 frequency means is that you had a number of people who didn't do any exercise at all, and the rest of the people, their exercise resembled a bell shape, with about number 40 being the most frequently exercise data. Now you've got water intake, and so that's close to a normal distribution, close to a bell shape. And the main water distribution is like maybe 2. So we'll say 2 liters. We're not sure exactly. But the main water distribution is 2. And then now we've got our pie chart. So you've got your diet type, which is a balanced, a veg, and non-veg. So the veg was the highest, but it was all 3 of them. It was close to a third each. Stress level was medium. That was the highest stress level. Sleep quality, again, so you had average and poor. So average was the number 1 sleep quality, but poor ran a close second. Physical activity level. So you had the moderate physical activity was the highest, but all 3 of them were about a third. Smoking and drinking alcohol, that yes was the highest, but no ran a close second, and then you had occasional as well. Gender was, most of the people tested were males, but 29.3% was females and 32.4% is other, but most of the people tested were males. So now we're going to analyze the test data frame, and we're going to use exactly the same code for the test data frame that we used for the train data frame. So again, the sleep duration is 7. Most people slept around 7 hours a day. The heart rate was pretty good. It was between around 75. I don't know if that's good or not. I'm not medically trained. BMI, that's your body mass index. So that's not too bad. And it does sort of look like a normal distribution. Calorie expenditure was a little bit over 2,000 calories a day. And then a few people had 2,000 calories a day. So step count looks like a uniform distribution. Exercise duration was very similar to the exercise duration in the train data set, whereas you had close to 10,000 people who didn't do any exercise at all. And then the most popular exercise duration was 40. Water intake, again, so that's like 2.2. And then now we talk about the diet type. And so basically in the test data frame, we had to say not listed. So you had 1% of the people weren't listed. And 33.5% of the people were vegetarian. The stress, you had 12% of the people not listed, whereas 38.1% of the people had medium stress level. Sleep quality, 8.5% of the people were not listed, but average and poor quality were very close to being the same. Physical activity, so 5.3% of the people was not listed, and sedentary and moderate. Well, sedentary was the most common, with moderate running a close second. Smoking and alcohol, 4.1% of the people were not listed, whereas 32.2% said yes, they smoked and drank, and so that was the highest percentage, with no running a close second. Gender, 3.1% of the people were not listed, and 4.6% people were male. So most of the people tested were male. So now what we're going to do is we're going to encode all of the object columns. So every object column that you have has to be encoded. But what we wanted to do was we wanted to check to see the number of unique values in each column of data that is a column, that is an object. And you can see that the number of unique values for every object column is 4. And so now what we're going to do is we're going to use sklearn's ordinal encoder to encode all of the object columns. And so this is going to be a little bit different. And the reason why it's going to be a little bit different is because we had to impute the null values. And because we had to impute the null values in the test data frame, we had to create an extra column. You had to create an extra category. And so the handle unknown is going to be use encoded value, and unknown value is 4. Max categories is 4. Encoded missing value equals 5. And there's lots of ways that you can impute. I mean, I just used one way to impute the missing data, and I decided that the best way to do it in the training data set was just remove all of the null values. But you could have imputed the trained data set exactly the same way that I did the test data set, but there's no guarantee, you have no guarantee of knowing the accuracy of your outcome. So that's why I made the decision just to drop all the null values. But we have encoded the columns of data for the trained data set frame and the test data frame. And so we used sklearn's ordinal encoder to do that. So now when you check on info, after we have encoded all of the object columns, you can see that all of the columns of data are now float. And so that means that the Extra Trees model will be able to train the data because the categories have been converted to numbers. So now we check for info, and you can see all of the columns of data are now floats. So now we're going to define our X and our Y variables. So Y is your target, which we have already created earlier on in the program, and X is your train, and X test is your test. We're going to use train test split with sklearn to split the X and Y variables into training and validation sets. And then we're going to check the shape of these data frames that we have created just to make sure that the data frames have the correct shapes. They all have 13 columns of data. They all have the same number of rows. So now we're going to define the model, and what I'm going to do in this instance is to use the Extra Trees Classifier. I chose the Extra Trees Classifier because it's not picky about training a target that has categories in it. And then I could have tried the random forest. I could have tried the random forest. And then so I selected number of estimators for 1,000 because my accuracy was just slightly better with 1,000 estimators. I chose class weight as balanced because this is definitely an unbalanced data set. And random state is 42. You can put any number you want there. And then I fitted your X train and your Y train, and then I printed the score of that train data, and it's 100%. And now I created the variable YPRAD, which is a prediction of the validation set. And so we've got widespread being at risk, fit, or unhealthy. And so now we've computed balance accuracy because that's what Kaggle wanted to see. That's the type of accuracy that Kaggle wanted to see. So, and then we printed the balance accuracy as being 96.64% when we made predictions on the validation set. And then I've created a histogram of widespread, and you can see you've got a few people are fit, a little bit more people are unhealthy, and the rest of the people are at risk. So now we're going to predict on the test set. And so we've got our pred is the prediction, and we're going to convert that to a histogram as well. And so you've got a few people are fit, a little bit more people are unhealthy, and most people are at risk. So that's the prediction, and I just made a histogram of that so you could see what the prediction was. And now what I do is I prepare the submission by taking pred and putting it in the health condition column, and then I create submission, I convert submission into a CSV file, and then I convert that CSV file into a data frame, and then I print the data frame so you can see what the predictions are. And then so what I do is when I submit my work to Kaggle, I got 83.096 accuracy. And the thing is that my score wasn't fantastic because there are people that scored a lot higher than I did. They scored like maybe 95% or maybe even higher. But you just have to work on it. The way that you're going to get the highest score is you're going to have to work on imputing those null values, and then you can look it up on the internet, say ways to impute null values, and you can try all the ways that you can think of to impute the null values, which I think it's a good blog post really, to impute null values. But I just use the mean, but there's lots of ways to impute null values. So that concludes this video, and I carried out a code review of my code for the Kaggle competition for predicting student health risk. And this is Season 6, Episode 7. So thank you so much for watching my video. If you like my video, please like and subscribe. And I'll be making another video for you very soon.